Alright, let's get started with 4.4, trig functions of any angle. So up to now we've been working on the angles that are on the unit circle, and so now we're going to jump away from the unit circle and any angle will work. So what we know now is that before sine was equal to y, well really it's always been sine is y over r, opposite over hypotenuse, but on the unit circle r is 1, so we didn't have to divide by 1. Alright? But if we jump off the unit circle and expand to being able to work with any circle, any angle, we need to involve the second side here, which is the radius. So formula is still the same. Cosine is x over r now, though, instead of x over 1. Tangent, y over x, which we've talked about tangent being sine over cosine or opposite over adjacent. All right, so the same formulas still work here, same setup, just expanding our knowledge slightly here. So starting with sine theta is y over r, cosine is x over r, tangent is y over x. And then cotangent, secant, and cosecant are the reciprocals, the flips of those. All right, so let's go in here and take a look at an example problem. Let negative 3 comma 4 be a point on the terminal side of theta. What that means is we're going to start in our standard position here on the x-axis, and we're going to spin until we have some angle, theta, which is the big angle. And I know we're in quadrant 2 here because the x is negative, but the y is positive, negative 3 comma 4. All right? And so our job is to figure out the sine, cosine, and tangent of this. And so we're going to have to go to our definitions. Sine is, by definition, going to be y over r, which is 4 over, don't know r yet, but we can figure it out. And I flipped over quickly because we've seen it before, but here it's x squared plus y squared. This is your standard Pythagorean. A squared plus b squared equals c squared. The radius is the equivalent of your c. Okay? Sorry, that kind of got crossed out there. R and C can be thought of as the same things when we're talking about the Pythagorean theorem. R is going to be your hypotenuse. All right, so here it's a 3, a 4. We know that R is going to be 5, right? We've done that before. Negative 3 squared plus 4 squared, 9 plus 16, square root of 25 is indeed 5. All right, so we can come up with the cosine as well. Cosine is x over r, and the cosine here is negative 3, and the r we know is 5. And then tangent. Tangent we could have gotten right from the get-go, didn't need to know r. Tangent is y over x. And so on this one we're going to say 4 over negative 3. Okay, and it doesn't matter if the negative's in the top or the bottom. We put the negative out front on this one. So negative 4 over 3. Use the, there's a little drawing there that is the same drawing we just did, but use that same thinking. See if you can figure out the answer for 9A and B. All right, example 2, evaluating trig functions, same sort of deal here. See the information. Tan theta is negative 5 over 4, so y over x is negative 5 over 4, right? Because tangent is y over x. The problem here is I don't know if the y is negative or if the x is negative. One of them is negative. I don't know which one. But then here it says cosine theta is greater than 0, which means cosine, which is x, is greater than 0. So x is the positive and y is the negative. So I know now that y is negative 5 and x is positive 4. So that's going to be down here in quadrant 4. Right? My angle would be spinning all the way around here. That's our theta. And to get to there, we end up at 4, negative 5. And so we can find sine and secant. Sine of theta is y over r, which is negative 5 over, don't know r, so r, let's do the Pythagorean theorem, 16 and 25, which is 41. So negative 5 over root 41. Let's rationalize that that denominator, and we'll get negative 5 root 41 over 41. That's our sine. And secant. Secant is the flip of cosine. cosine is x over r, so secant is going to be r over x. Our r is root 41, and our x is 4. Don't need to rationalize that denominator. We're good to go. Root 41 over 4. All right, your turn. 23. Okay, let's try this one. Evaluate the tangent functions at the 4 quadrant angles. 0, pi over 2, pi, and 3 pi over 2. And so this one is fairly straightforward because on all of these, our radius is 1. Our radius is 1. Our radius is 1, and our radius is 1 here. All right, so cosine and tan is what we need to be able to do. Cosine of 0 equals x over r, 1 over 1, which is just 1. Tan theta, 0, we know theta, is y over x, which is 0 over 1, or just 0. All right, so we'll spin all the way around. Cosine up here is the x over r, which is 0 over 1. Tangent is going to be undefined because it's 1 over 0. Cosine over here is going to be negative 1. Tangent is going to be 0. And then down here as well, cosine is going to be 0, which means that the tangent is undefined because it's going to be 1, or negative 1 in that case, divided by 0. See if you could tell me the sign of pi. All right, so we've got all 4 quadrants. The reference angle means, see if you could tell me the angle if we moved it back into quadrant 1. So what we're saying here is draw from the tip of your terminal side of your angle and go straight down to the x-axis to make yourself a triangle. And then ask yourself about the inner angle, the one closest to the origin. What angle would that be? All right? Well, that would be the same thing as 180, because that's all the way over to here, minus whatever we started with, right, to find that angle in there. If we did the same thing over here, go to the tip of your terminal, go straight to the x-axis, what's this in here? It's going to be 180, but this time not minus, this time plus whatever that angle is in there, okay? And so we can kind of figure out what's the angle going to be if we moved it over and put it into quadrant 1. All right, are we going to have to add 180, are we going to have to minus 180, or are we going to have to subtract from 360 like we're doing in quadrant 4? So let's try a problem and see if we can figure this out. Find the reference angle for theta prime. So 300 degrees is over here in quadrant 4. So to get there, we spin around here like that. That's 300 degrees. That would be our theta. Well, let's figure out our reference angle. The reference angle is if we go straight to the x-axis and figure out this angle in here. All right? Well, if the whole thing all the way around is 300, and going a full circle is 360, the part that's left over in here must be 360 minus 300. So we're left over with a reference angle, theta prime, of 60 degrees. All right? So if we asked what's the tangent of 300, we could just look at the tangent of 60, right? And then we would just be careful with our signs, because when we move into the quadrant 4, we do have different signs, positive, negatives, than in quadrant 1. All right? Let's talk about 2.3. So all of a sudden we've got radians here. So a little trick here. 2.3. I don't have a good option of visualizing 2.3, so I like to turn this into degrees to have a better picture for this. So to turn something into degrees, we're going to go times 180 over pi. No pi to cancel out, but it will still cancel out the radians. Let's grab the calculator. 2.3 times 180 divided by pi. 131.78. All right, so we'll call that quadrant 2. So this is 131.78. What's this going to be? It must be 180 minus 131.78 to figure out what's left over. And so that's going to be 58.22 degrees. And we could turn that back into radians if need be, if the problem specified that we had to be in radians. All right, how about negative 135? So what can we always do to an angle? We can always add 360, add a full circle to it. And so that's going to be 225. Let's ask ourselves where 225 is. That's in quadrant 4. Okay, so on this one, our angle here is 225. What about just this part of it? So on this one, we would say 225, take away 180, because we want to get rid of the first 180 degrees and just worry about the leftover piece. All right, so that's 45 degrees, and that's what our reference angle would be. 225 has a reference angle of 45 degrees. See if you can find the reference angle for 160 degrees. All right, so the chart here, very helpful to have in your notes. This is the chart for sine, cosine, and tangent of all of our common angles, right? 30, 45, and 60 are the three in between our cardinals of 90, 180, and 270. Remember that 0 is the same as 360, so this is a full circle coming around. All right, so if you have this chart, this is really what you need to memorize to be able to fill it out. And again, sine for all these angles counts up from 0 to 4, square root of those, all over 2. So if you can memorize this, everything else comes off of this list, right? Cosine is the reverse of this. The cosine of 0 is root 4 over 2. It's the reverse, counting down. All right, let's evaluate each trig function here. The cosine of 4 pi over 3 using reference angles. Okay, so if we look at this, we have 4 pi over 3. That would be in quadrant 4. So the reference angle here is pi over 3. Okay, we can do that by minusing pi, minusing 180 degrees, which is 3 pi over 3. Cosine of pi over 3, if we flip back to our chart, the cosine of pi over 3 is right here. 1/2 is what we would end up with for this. And then we just need to ask ourselves, which quadrant are we in? We're in quadrant 3. In quadrant 3, are the x's, because that's what cosine is x values, are those positive or negative? And they're negative. So our answer would be negative 1/2. Let's talk about tan of negative 210. That's the same thing as 150. Okay? So 150, we're in here, and so the reference angle would be 30. So now we're talking about the tangent of 30. Let's flip back here and look at our chart. The tangent of 30 is root 3 over 3. So our answer is root 3 over 3. Let's think about our signs. In quadrant 2, x's are negative, y's are positive. Remember, tangent is y over x. A positive divided by a negative, that's going to be a negative answer. So we would have negative root 3 over 3 for the tangent. And lastly, cosecant of 11 pi over 4. 11 pi over 4 has a reference angle of pi over 4. And remember, cosecant is the flip of sine. So let's go figure out what the sine of pi over 4 is. Jumping back to our chart, sine of pi over 4, root 2 over 2. And so this is 1 over root 2 over 2. Flip that over, you just get root 2. Let's think about our signs. The sine, S-I-G-N, of sine. In quadrant 2, y is going to be a positive up here. So this is going to be a positive root 2, and we're done. See if you can use the same thinking. For 59, tell me the sine, cosine, and tangent of 2 pi over 3, thinking about it using the reference angles of 2 pi over 3. All right, 2 to go here. Example 6, let theta be an angle in quadrant 2. I'm going to pause right there and just sketch out an angle into quadrant 2. And sine theta is 1 over 3. So here's what I'm going to do. I'm going to drop down, make an angle, and theta. And from that angle, sine is opposite over hypotenuse, right? Sine theta is O over H. The other way of thinking about that is y over r, right? Our radius is 3, and our y value is 1, something comma 1. And so we would need to figure out the x value here. Pythagorean theorem, 9 equals 1 plus x squared. So this is going to be root 8 as x, which is 2 root 2. Okay? All right. The thing that will get this problem wrong for you more than anything else is forgetting that in quadrant 2, x is a negative. So the cosine is negative 2 root 2 over 3. Remember, it's x over r for cosine. Tangent, which is y, put this in here, 2 root 2 over negative 2 root 2. Tangent is y, 1 over x, negative 2 root 2. We're good, except we need to rationalize this. Let's times top and bottom by the root 2. Not by the 2 root 2, just the root 2. And we end up with root 2 over negative 4. And that would be our answer. Your job's 69. Sine theta is negative 3 over 5. See if you can figure cosine theta if you're in quadrant 4. All right, and last one, we're going to the calculators here. Cotangent of 410. Okay, just walking through the steps here. Make sure we're good on these as well. Cotangent of 410, we're in degrees. So first thing we do, mode, check we're in degrees. We are. Cotangent is the flip of tangent. So I'm going to do the tangent of 410. Get an answer, and then x minus 1 will flip me over. So 0.839 is my answer for A. How about this? Negative 7. Is this in radians or degrees? Do not see a degree sign, so this is in radians. So let's go to mode. We're going to change it to radians. Second quit gets me out of there. And right now we just do sine of negative 7. That's all we need to do. Don't need to flip it over. Negative 0.657. Last but not least, secant of pi over 9. This is in radians as well, which we're already in. Secant is the flip of cosine. Cosine of pi. We can put pi right in there. Don't type in 3.1419159. Okay, use pi. Divided by 9. We get that. That's cosine. We want secant, so we need to flip this over. Right here, x to the negative 1. Answer to the negative 1 flips it over. 1.064177772. And there you go. Your job is to do 79, and then you are done. Questions, we'll go over them in class.